Industrial manufacturing is a highly demanding environment that requires machines capable of extreme physical force, operating at very high velocity. To understand how these machines actually achieve this, we can look to Michael P. Groover's foundational framework on robot technology and applications. Groover defines industrial robotics as a strict applied engineering science. It requires the synthesis of two distinct disciplines, machine tool technology and computer science. These fields are completely interdependent. You cannot write effective motion control software without first mapping the microelectronics, control theory, and mechanical design of the arm itself. Before an end effector performs a single joule of work, the physical constraints and geometry of the entire mechanism must be defined. The software running the machine is entirely subordinate to its hardware. Ultimately, a robot's programming is only as precise as its physical rigidity allows. The Selective Compliance Assembly Robotic Arm, or SCARA, is a primary example of how structural configuration dictates capability. Its distinct horizontal joint layout provides inherent structural rigidity, making it highly advantageous for precise horizontal assembly tasks. Compare that to a Cartesian configuration operating on a linear box frame XYZ axis. Because it moves along rigid linear tracks, the Cartesian structure possesses the highest mechanical advantage for reaching a point in space with the absolute minimum motion error. For applications requiring a different range of motion, engineers rely on polar and jointed arm configurations. The specific physical advantage here is superior reach. These designs allow the robot to extend its manipulator significantly beyond its own base. Other models, like the cylindrical and gantry configurations, are deployed when the process demands high load carrying capacity or the ability to reach into tight machine openings without side interference. The exact geometry an engineer selects on day one permanently locks in the system's baseline limits for rigidity, reach, and payload. Productive work requires the manipulator to navigate three-dimensional space, and that navigation is split into two divided spatial motions. The blue sections represent arm and body motions. These large mechanical links are responsible for the macro positioning of the robot within its work volume. The red sections represent.
Thanks for watching. Stay tuned.